Hello, everyone, and welcome to our session today. Before we get started, I wanted to take a moment to go over the Microsoft Code of Conduct. At Microsoft, we want to provide everyone a safe and inclusive environment for all of our participants who are participating in this session today. What we encourage everyone is to be respectful and thoughtful of each other. We do not tolerate any misleading behavior, so please be thoughtful of each other's time. Now, with that, let me go ahead and introduce the session. So today, this session is about deploying voice assistants for driverless vehicles. With us today is, with myself, Asrar, today is Jonathan Marston from Optimus Ride, as well as Peter Nguyen from Optimus Ride, who lead the core engineering teams at Optimus Ride. Now, before we get started, I want to quickly talk about the Microsoft for Startups program. So really, the Microsoft for Startups program is focused on two key components. One is access to technology and access to customers. For Microsoft for Startups program, it's an equity-free program, and it's designed for seed to Series C B2B startups. Now, when we talk about access to technology, we provide up to $120,000 of free Azure Cloud, powerful developer tools like Visual Studio and GitHub Enterprise, in addition to Microsoft Power Platform and collaboration tools like Office 365. We also offer architectural design sessions along with one-on-one consultations with our engineering teams. And then the second pillar is sort of focused on business acceleration, where we connect our innovative startups with enterprise customers, where our startup engagement manager, who is dedicated to help startups navigate the partnership with Microsoft. To learn more about the program, go to startups.microsoft.com. But really today, we're talking about autonomous driving, because with all the innovation that's happening with machines and at the pace at which it's happening, there's tremendous need for innovation, and there's significant digital transformation happening in this space. Now, this technology space is very unique with its complex set of challenges and sophisticated solutions. So we have invited Optimus Ride to talk about how they're overcoming some of these complex challenges with us. So I'll hand it over to Optimus Ride. Peter, over to you, please.
Thanks, Asrar. So hello, everyone. My name is Peter Nguyen, and I'm the Fleet Software Technical Lead at Optimus Ride. So for this session, we're going to talk about Optimus Ride and what its business model is and what our mission is, as well as a deeper dive into our in-vehicle experience platform and how we've spent the past few months integrating Microsoft's voice assistance tools and architectures into our system. Next slide, please. So at Optimus Ride, we deal with autonomous vehicles. And to begin this conversation, I'd like to talk about what self-driving cars cannot, or at least at this current moment, have a difficult time doing. And a very good example of this is the notion of driving from Harvard Square to Times Square. Now you can imagine that there's a variety of different complexities when it comes to going from point A to point B, some easier than others, but the most difficult, the most complex problems involve driving in more urban spaces, in spaces with a lot more obstacles and variable conditions, especially when talking about things like precipitation and loss of visibility as a result of that, things such as pedestrians and bicyclists and kind of stop and go traffic. A lot of these parameters that make the autonomous driving, the self-driving car solution difficult to achieve. So at Optimus Ride, we take a very kind of measured, very direct approach to this problem. And next slide, please. We focus specifically on this subdomain to begin with. So the notion of operating our self-driving vehicles in well-defined geofenced areas, as well as operating within those areas in lower speeds. kind of working towards the goal of the first to last mile solutions, first mile solutions and last mile solutions, as opposed to kind of solving the entire space to begin with. The idea being that this can act as a way for us to kind of rapidly iterate on our engineering and technology and be able to expand rapidly. So a little bit more about Optimus Ride in general. Optimus Ride is an MIT spinoff that was founded in 2015. And our focus is on lower speed electric self-driving vehicles with a focus on sustainability, kind of energy efficiency, and environmental consciousness. Next slide, please. The company operates in the Boston Seaport District, and it's really useful in terms of being able to both kind of develop our technology as well as test our technology in the same location. So our headquarters, in fact, acts as one of our geofence locations that we operate in. We treat that as a deployment as well. And on a regular day-to-day, you'll see our fleet of vehicles going around the seaport area, collecting data, doing safety runs, kind of just evaluating our technology. And in addition to our deployment and our operations in the Seaport District of Boston, we also operate in 4 other locations at this time. Next slide, please. Yes, thank you. We also operate in Paradise Valley, which is located in Fairfield, California, where we to the retirement community there. So have a deployment at the Haley Rise location, which is an office park managed by Brookfield in Reston, Virginia. Our latest deployment is at the yards in the DC area, where we're working towards a delivery service. And lastly, we operate in the Brooklyn Navy Yard to shuttle people from the ferry to connect them to the subway system. And in fact, that is the first self-driving deployment in New York City. Now, to take a deeper dive into the technical components of this talk, I wanted to spend some more time about the work that the team has done towards our in-vehicle experience platform. Now, what is this? It's basically the touch point between passengers in the vehicle and the self-driving technology. You can imagine in a case like Uber or Lyft, when you get in a vehicle, you have interactions with a human driver in the front of the vehicle. But that paradigm, that kind of assumption is no longer present in the context of a vehicle without a driver. So there needs to be some sort of way for the passenger to be able to interact with the system, get a sense of assurance that the vehicle is doing what it's intended to do, and be able to communicate to the passenger otherwise. And we establish that through a set of software as well as a display screen near the front dash, as you see in the photo, as well as with a speaker and microphone system for you to interact with the vehicle, as well as with a human operator in the event that a person needs to be added to the loop. Now, when it comes to the user experience and the passenger experience in the vehicle, we thought to ourselves, we have these visual cues and we have these kind of audio cues as well, such as when there's a notification such as, oh, the doors aren't closed and the seatbelts haven't been buckled. But that's insufficient. If you compare it to a situation like when you're speaking with like a taxi driver, or when, for instance, when you're in a plane and you're hearing announcements from the captain, those sorts of more human-like touch points kind of give the passenger more of the information that they need to understand what's going on in the current situation, but at the same time, not overwhelm the passenger with information that's unnecessary to give them a comfortable, safe experience. And with those ideas in mind, we wanted to integrate some of the technologies provided by Microsoft to give the vehicle more of its own voice and be able to communicate with the passenger. So what does this look like in practice then? Our product team, alongside our engineering team and executive team, kind of had this vision, this idea, this journey of what a passenger's experience would look like from the moment they get into the vehicle through the process of going in transit to their destination, and lastly, reaching their destination and getting out of their vehicle. And those elements in green, those green boxes, were the pieces that we determined were the most important pieces to have a notion of a speaking aspect. Perhaps a notion where it would be more useful for there to be someone or something speaking to the passenger and telling them what's going on, or perhaps even more than that, have a way for the passenger to be able to speak with some entity. And as a kind of canonical example of this, one can imagine an example where a passenger would like to go someplace else. Let's say they decided to go to point A, but at some point during their ride, they might get like a notification or a text message from something saying, oh, you need to go somewhere else first. Oh, could you pick something else? And they'd like to change their destination. Now, before we added the voice assistant capability, the only way we could really communicate to the vehicle in any sense would be to establish a conversation with a human operator. And they would do that by pressing the support button that's in the vehicle, and they would be patched to a human operator, at which point the operator could service the person's request. But now, with the addition of the voice assistant instead, what they can do is they'll press a button, it'll activate the voice assistant, and from that point onwards, that kind of servicing of the request can be handled by the voice assistant rather than through the remote operator. And the idea behind that is that you're able to kind of deal with the kind of simpler use cases of, oh, I'd like to change my destination, or, oh, I would like to pull over, or things like that, before having to connect with a human operator. The idea of kind of being able to catch the simpler cases first. Next slide, please. Now, of course, the voice assistant won't be able to handle all use cases. Voice assistant is meant to act as a go-between between the human passenger and the human remote operator. And there are some cases where it's just necessary to speak to a human operator. So in those scenarios, it'll proceed to patch you to a human operator. But in the case where it's something simple such as, oh, I'd like to go someplace new, all that would need to happen is the bot will then proceed to notify the human operator of the passenger's request without having to go through the long-winded approach of starting another conversation, servicing the request, and then changing the destination. So that's the user journey in a nutshell. Now I'll pivot and spend the next portion of this talk going into a bit more detail on what the current architecture of the in-vehicle experience system looks like, as well as the components that we used as part of Azure's offerings to integrate a voice assistant onto our system. Now, the architecture as it stood consisted of as follows. So on the left-hand side, you'll have the self-driving vehicle autonomy stack. And that'll deal with all sorts of things such as obstacle detection, kind of understanding what the physics of the vehicle are at the current moment. But what's relevant to the passenger is a very small subset of that information. And what we have on the right-hand side is our current or our recent in-vehicle experience software stack, which kind of establishes its own model of the vehicle state and keeps track of the subsets of information that would be relevant and useful and valuable for a passenger to know about. And that system will then send messages to the display and basically show visually or send audio notifications to the passenger, things that are useful for them to know about. And then lastly, as needed, they can get patched to a human operator for a more live conversation in case there's something that a passenger needs. Next slide, please. Now, how do we go from there to now in-vehicle experience system with the addition of a voice assistant? Now, to go into a bit more detail on that, if you look on the left-hand side this time, you can think of there being two major components. The vehicle component acting as a client to this voice assistant platform, utilizing the platform speech SDK. And then there's the entire right-hand side, which is all the Azure cloud managed services that deal with all sorts of problems that need to be solved when it comes to voice assistants, such as being able to define conversational flows, being able to understand when and how to prompt the passenger for more information, as well as more nuanced things, such as being able to, given some nebulous phrase given by the passenger, to understand with some higher semantic meaning what the intention of the passenger's phrasing was. And then lastly, being able to translate that entire session in a spoken vocal way, as opposed to the way that machines would talk to each other. Next slide, please. So to start with the foundation, before we have any notion of any spoken word or speech to text or text to speech translation or anything like that, the very first thing that we need to solve is how do we have a bot that understands this notion of conversations and dialogues to begin with. You can imagine, as an example, a use case where you log into your banking institution's website and you see this chat bot that might pop up in the corner asking you for any questions you may have, or saying if you need anything, feel free to type into this chat box. It's not a human under the hood, but just a bot. So the idea is the same here, where fundamentally we have this bot and we use Azure's Bot Framework SDK to define a series of conversational flows and sets of dialogues that understands things such as, okay, the user gave me this prompt, which implies that they want to change their destination. And so the bot will be smart enough to know to proceed to ask questions such as, okay, where would you like to go? Is this where you would like to go? And things such as that. Next slide, please. Building on top of that, Microsoft has recently published a newer version of their Bot Framework Composer, which acts as a visual canvas tool that allows you to drag and drop conversational components together. Basically, you can think of it as like Lego blocks that you kind of put together to make something more meaningful. And the idea is you can lay bare these entire conversations as workflow diagrams and be able to intuitively see where prompts are being solicited, where branching points in the conversation occur, and things such as that. And this has been very powerful for our team at Optimus Ride, because not only has this tool been very useful for the engineering team to very rapidly iterate on the bots that we've been building, but we've also been able to loop in our product team and be able to get more rapid feedback from them, because the interface that's offered by the Composer tool is a lot more intuitive to understand than just looking at source code. Next slide, please. So now we have a bot that we can quickly build and quickly iterate on. Now, the next step is for the bot to be able to understand what a passenger is saying. So going back to the changing destination example, you can imagine that a passenger might phrase that in a number of different ways. And the objective of Lewis is to be able to match that very undefined, kind of very nebulously defined sets of ways that someone could say something and map that to a very concrete notion of what did the person actually mean. So let's say I might phrase it such as, I would like to go someplace new. Oh, I would like to change my destination. But unlikely would a person phrase it in such a way that a very rigid bot would understand in a regular expression context, such as change destination or anything kind of very stilted such as that. And how Lewis works is we provide it with data sets that effectively trains a machine learning model under the hood. And as we pass it new data, new examples of utterances when it's working live, it's able to use the data and the model that it produced during its training phase to have a better sense of what you intended, what you meant when you were saying what you said, and be able to respond intelligently in response to that. Next slide, please. So we're almost at the finish. We have a bot now that understands these various conversational flows, these various dialogues, and can also have a better sense of matching a variety of different phrasings to finite, well-defined things that we're meant to service. Now, the last piece is being able to actually give the bot and give the vehicle a voice. And for that, we use the Direct Line Speech SDK. And that acts as an all-in-one solution where they have all of their speech-to-text, text-to-speech services all co-located in the cloud, and allows you to, through their SDK, just merely turn on your microphone, kind of say what you need. So in this case, I'd like to go someplace else. Be able to, without any additional manual API calls of one's own, be able to translate that into text, feed that text to the bot, and then take what the bot responds with and translates that into something spoken as well. And with the Direct Line Speech SDK, there are a number of different technical options to select from when it comes to integration. And the ones that we drilled down on were either the C++ SDK or the JavaScript SDK. Main advantages that we initially saw with the C++ SDK being that it gave us more customizability when it came to audio hardware support, such as if we wanted to use something more nuanced like microphone arrays, and also if we wanted to support something like wake words to trigger the voice assistant. But on the other hand, we found the JavaScript option attractive due to its very simple interface and due to the fact that the display screen that we had implemented was also using JavaScript. So for that reason, we decided to stick with the JavaScript SDK for rapid deployment. Next slide, please. So to kind of sum that all together, this is what the in-vehicle experience architecture looks like now, integrated with the Azure bot solution for voice assistance. So now, rather than having to kind of report to the remote operator or to patch a call every time a passenger needs to kind of provide input or anything like that, what they can instead do now is press the support button in the vehicle, establish a conversation with the voice assistant, and then rely on the voice assistant to make sense of what it understood based on the conversation that I just had with the passenger. And then as a result of that, produce a JSON payload, this machine readable representation that succinctly encapsulates what the passenger asked for and sends that as a notification to the remote operator. And this gives us a lot of power because it allows us to scale a lot more easily, where these simpler use cases can be handled by the remote can be handled by the voice assistant. And for the more critical cases, we can then proceed to the remote operator. So for the video demo, we had displayed in the last section as well. I would encourage folks who are curious to see it live in action to visit optimusride.com and to see how everything is integrated together, as well as see a little bit of our vehicle.
Thank you, Peter. And with that, it's a wrap. Unfortunately, we don't have enough time to answer the questions, but we would like to thank all the attendees who joined us for this session. Thank you again, and enjoy the rest of Build. Thanks all.
Thank you.